Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain another examples of prediction questions for paper 2 IB chemistry standard level. It is 100% not guaranteed that this question will appear in the exam. Instead, you can treat these questions as a mock exam to check whether you're ready for the exam or to investigate what kind of topic that you're still struggling with. If you find this video is helpful, please don't forget to subscribe and let the other friend knows about my channel to support me. I wish you good luck and let's get started. Methane is an example of a fossil fuel. Deduce and draw the VSEPR molecular geometry for methane, stating the name of the structural shape. So this would be the structure, or you can do it this way. And this would be tetrahedral. Deduce the balance equation for incomplete combustion of methane. Methane CH4, when it is incomplete combustion, will produce carbon monoxide and H2O. So you need to balance them. This would be 2, this would be 3, 2, and 4. Calculate the enthalpy reaction for incomplete combustion of methane using section 11 of the data booklet. That would be the bond average enthalpy. So CH4, CH, H and H, so that would be 2 CH4, so it will be 8 CH plus 3 O double bond O, 2 CO, H2O, it's like this, so that would be 8 OH. So 8 times 414 plus 3 times 498, 2 times 1077 plus 8 times 463. So this would be 4806, and this one 5858. So delta H would be 4806 minus 5858. That will be negative 1052 kilojoule. State 2 reasons why the answer in C would differ for the enthalpy value obtained if the enthalpy of combustion for methane was measured in a laboratory, because bond enthalpy are average for the bond types in various bonds. And the second reason is the enthalpy measure in a lab would have experimental error, for example, heat loss to surrounding, right? Write the balance equation and calculate the mass of methane that would need to be completed combusted at STP to produce 20 centimeter cube of CO2. So when it is completely combusted, so CH4, when it reacts with oxygen, will produce CO2 and water. So we need to balance them. This would be 2. And we've got volume of CO2, so we can calculate mole. So V divided by Vm. So 20 divided by 22.7, which is 0.881. And the question is the mass of methane. So for CO2, the coefficient is 1. CH4 is also 1. Therefore, this also equal to mole of CH4. So now calculating the mass would be N times Mr. That would be 0.881 times molecular mass of methane, which is 16.05. So that would be 14 gram CH4. Of the fossil fuels, explain why coal has the greatest tendency for incomplete combustion. Coal has more impurities like nitrogen, nitrogen, sulfur, and metals that also react with oxygen. Thus, it costs less oxygen is available to react with coal. When a material is combusted, all of the atoms will react with oxygen until the oxygen is finished or there is no more oxygen is available. Clean fuel like methane, all methane will react with all available oxygen. It's not like coal that is impure. So as the other materials that are available or that are contained in the coal due to impurities react with oxygen, so less fuel will be available to combine with carbon and hydrogen atoms, resulting in complete combustion. If methane was exposed to Cl2 in the upper atmosphere, propose a reaction type that would take place and one of the organic products that would form. That would be CH3, Cl, or CH2, Cl. So the type of reaction that would be free radical substitution. So when CH4 reacts with Cl2 under UV radiation, a free radical substitution will occur. So the hydrogen atoms in CH4 is replaced by chlorine atom. Magnesium is a combustible metal that is used in fireworks. State the electron configuration for magnesium metal atom. So Mg with the number of electrons is 12. So 1s2, 2s2, 2p6, 2p6, 3s2, 3s2. Calculate the ionization energy in kilojoule for a single magnesium atom given a convergence limit of 1.85 times 10 to the power 15 s to the power negative 1. So E, H times V. H is a Planck constant, which is 6.63 times 10 to the power negative 34 times frequency, which is 1.85 times 10 to the power 15. You'll get 1.23 times 10 to the power 21 kilojoule. Calculate the wavelength of a photon in nanometer that would allow for the first ionization of magnesium using the energy calculated in B. So wavelength would be H times C divided by energy. So Planck constant 6.63 times 10 to the power 6.63 times 10 to the power negative 34 times speed of light 3 times 10 to the power 8 divided by the energy, this one, 1.23 times 10 to the power negative 18. That would be 1.62 times 10 to the power negative 7 meter. So when you convert it to be nanometer, that would be 162 nanometer. When magnesium is exposed to hydrogen gas, it forms magnesium hydride. The chemical formula, it's MgH2. Oxidation state of magnesium. So MgH2, this will be plus 2. This will be negative 2 and negative 1. So this one plus 2, negative 1. Magnesium can be found in magnesium hydroxide. State the types of bonds present in magnesium hydroxide. So MgOH, when it dissolves in water or when it dissociates, will produce Mg2 plus ion and OH minus. So the types of bond that present in magnesium is ionic due to the electrostatic attraction of opposite ions, Mg2 plus and OH minus. And also it has polar covalent bond, as there is OH bond present, OH. Okay, deduce the balance chemical equations including state symbol for the combustion of magnesium metal. So Mg plus oxygen will produce MgO. So this would be 2 and this would be 2 as well. If 2.1 gram of magnesium and 1.5 decimeter cube of oxygen were combusted in STP, calculate the mass of product form. So 2 Mg plus O2, 2 MgO. So the mass of magnesium 2.1 divided by its molar mass or atomic relative, so 24.31, which is 0.086 mole. And for oxygen, that would be 1.5 divided by 22.7. We're now looking for the remitting reactant. Okay, so for oxygen, 0.066 mole for 1 oxygen, but for Mg it's 0.086 for 2 Mg. So for 1 Mg it's 0.043. Therefore this Mg is the limiting reactant. So now for mass of MgO, we can refer to the limiting reactant, but not this one. This one only to check which one is the limiting reactant. So we still need to revert to 0.086. It has the same coefficient, so mole of MgO is 0.086. To find the mass, N times Mr, which is 0.086 times 40.31, which is 3.5 gram MgO. Magnesium reacts with hydrochloric acid, HCl, according to the following equation. Calculate the molar enthalpy of reaction in kilojoule per mole for Mg if 0.62 gram of Mg reacts with 120 gram of 0.8 mole per decimeter cube HCl, resulting in a change temperature from 21 degrees Celsius to 38.9 degrees Celsius. So delta T will be 18.8 degrees Celsius. So let's calculate Q, which is MC delta T, directly delta H, I think it's easier. So delta H mean Q over N. So negative because of the temperature increase, so that's why it's negative, so it's exothermic. So before that, let's calculate mole, which is 0.62 divided by 24.31. It's 0.0255 because the mass is known. So divided by molar mass of Mg. So now let's plot into the formula. Negative 120 times 4.18 times 18.8 divided by 0.0255, which is 369,807 G per mole. And if we convert to kilojoule per mole, we just make it into 3 significant figures, so 370 kilojoule per mole. Alkenes are reactive organic molecules known to react in electrophilic addition reactions. Deduce structural formula of the product from the reaction of but2-ene with Br2. So Br2 will go right here and then right here, and the double bond will be single bond. It's an addition reaction, so it will be right here like this. Let me just make it nicer. So like this, like this, like this, So this would be Br here and Br here. This bond breaks. Okay. State the IUPAC name for of the product form. So this would be CH3, CH, CH, CH3. So there are 4, 1, 2, 3, 4, and 2 and 3 for the bromine. So 2.3 dibromobutane. Dibromobutane. Alkenes can also form alcohols when react with water. State the types of intermolecular forces that would be exhibited in propan 2O. Okay, propan 2O has OH because alcohol, and then they will have, as they have hydrogen bond, so they will have all the types of intermolecular forces, which is London dispersion force, and then dipole force, and then hydrogen bond. So hydrogen bond because it has OH, obviously, and then for dipole force because it is polar, it exhibits this force, and then for London dispersion force, all molecules exhibits London dispersion force, whether it's non-polar or polar. Deduce the order in boiling points from least to greatest for the following molecules, explaining your reasoning. Okay, this one is alkane, this one is alcohol, this one is aldehyde. So there is OH right here, and this one is CH, C double bond O, and then H. So this one is non-polar, this one has hydrogen bond, and this one has C double bond O. So because this is non-polar, only has London dispersion force, so it has a lowest boiling point. For this one, it has hydrogen bond, so it will have highest boiling point, because aldehyde only has dipole forces due to C double bond O. So it is polar, but it doesn't have hydrogen bond. Therefore, this would be in the middle. So the answer, if it's from the least to the greatest, so that would be CH3CH2, CH3, smaller or has lower boiling point than aldehyde, and then this lower than alcohol. Carboxylic acids and carboxylates can react in an equilibrium with ammonia. State the Kc expression for the following reaction. So Kc would be CH3CH2COOH, and then NH3, NH4 plus, and then CH3, CH2COO minus. State and explain what would happen to the product yield of the equilibrium if ammonia were added to the reaction mixture. Equilibrium, or the reaction shifts to the left, the yield decreases, because when ammonia is added, it will react more with propanoic acid to form more reactant. Therefore, the equilibrium will shift to the left. When the temperature of the reaction in E is increased, the yield of the ammonia is reduced. Deduce whether the forward reaction is endothermic or exothermic, and whether Kc increases or decreases. So let me just copy down the reaction again. Okay, so whether it is exothermic or endothermic, when the temperature of the reaction increase, the yield of the ammonia is reduced. it means the reaction shift to the left, right? So when the reactions shift to the left, when the temperature increase, it means this should be endothermic, because when the temperature increase, so it absorbs the energy, so it is an endothermic, so it favor endothermic reaction. So this one should be exothermic. So the forward reaction should be negative, because forward reaction is exo, delta H should be negative. So the forward reaction is exothermic. And what about Kc? Because the yield of ammonia is reduced, so the Kc decreases because the yield decreases. Electrochemical cells can be used to produce energy. Identify the reducing and oxidizing agent in this reaction. This would be +1, and this 0, this +2, this 0. So the reducing and oxidizing agent, oxidizing agent. Okay, reducing would be oxidation. Oxidation would be Cu. So this would be Cu. Oxidation, Cu as a reducing agent. And then 2Ag plus would be oxidizing agent. Deduce the half reaction at the anode and cathode. Anode experience oxidation, cathode experience reduction. So at the cathode would be 2Ag plus 2 electron produce 2Ag, and for the anode would be Cu2 plus 2 electron, because cathode experience reduction is gaining electron, anode experience oxidation reduce electron. Annotate the following diagram indicating the direction of the electron flow and the material that compose the anode and cathode. Cathode will be Ag. Okay, cathode will be Ag, and then anode will be Cu. The direction of electron flow, it is from anode to cathode. So we circle this one. Describe the function of the salt bridge to maintain or to balance charges in the electrochemical cell. Because anode Cu experience oxidation, so it will produce a lot of Cu2 plus right here. So the electron produce and losing the electron will flow to the Ag, to the cathode, so it will be 2 negative, right? And this one will be 2 positive because of Cu2 plus. So the salt bridge, which contains negative ion, anion and cation, so anion will go towards here because here is 2 positive, and then cation will go towards here because this is 2 negative. So that's why the function of the salt bridge is to balance the charge in the electrochemical cell. Organic molecules can also undergo redox reaction. Deduce the structural formula of the product of the following reaction. So this one is ketone. NaBH4 is for reduction. So ketone, when it is reduced, becomes a secondary alcohol, because secondary alcohol, when it is oxidized, produce ketone. So the structural formula of the product would be like this, and this would be OH. There is H right here. Organic molecules can react in variety of ways. Propanoic acid CH3CH2COOH is a weak acid. Deduce the balanced chemical reaction for the neutralization of propanoic acid with NaOH. CH3CH2COOH when it reacts with NaOH. So this is liquid, this is aqueous, will produce CH3COONA aqueous plus H2O liquid. Calculate the volume in decimeter cube of 0.5 mole decimeter cube NaOH required to neutralize 1.05 gram of propanoic acid. So CH3, CH2, COOH. Okay, we can just refer to the reaction above. So now we know the mass of the NaOH. So we can calculate the mass, the mass of propanoic acid. So mole of propanoic acid is 1.05 divided by molecular mass of propanoic acid, which is 74.09. We've got 0.0142 mole. The question is to calculate the volume of NaOH. So now we need the mole of NaOH. You can see the coefficient of NaOH and propanoic acid are equal. Therefore, this is also equal with mole of NaOH. To calculate volume, N divided by C, N is 0.0142 divided by concentration, which is 0.5. Then we've got 0.0283 decimeter cube. When butane 1-ol is oxidized, either butanol or butanoic acid can be formed. State and explain which technique will yield which product. So this one is aldehyde, this one is carboxylic acid. So when forming, a primary alcohol or butan 1-ol is oxidized, there will be butanol formed via distillation. If the butanol or aldehyde is not removed from the reaction mixture, it will continue reacting to form butanoic acid via reflux. So forming aldehyde is the oxidation reaction through distillation, and forming butanoic acid is an oxidation reaction through reflux from primary alcohol. In the oxidation of butane 2-ol to form 2.5 gram of butane 1-ol reacted in 3.5 minutes, calculate the rate of formation of butanol in mole per second. We need to find mole first. Mole of butanol, it's 2.5 divided by its molecular mass, which is 74.14. It's 0.0337 mole. And you know, when butane 2-ol forming butanol, the coefficient are the same, so this is also mole of butanol. So the rate of reaction to form butanol, that would be 0.0337 mole times 3.5 minute, and should be per second, so that would be 1 minute per 60 seconds, right? So minute, so that would be 1.6 times 10 to the power negative 4 mole per second. Explain how an increase in temperature would affect the reaction rate according to collision theory. Increase the temperature will increase the rate of reaction, causing a greater frequency of collisions. Because if you increase the temperature, the energy will increase, so the energy of the particles in the whatever things that is colliding will increase more. The collisions will happen more frequently, so the rate of reaction will also increase. That's all for the explanation for another predictions IB Chemistry Paper 2 standard level. I wish you a good luck for your exam. Again, if you find this video is helpful, please don't forget to subscribe and let your other friends know about my channel to support me. Thank you for watching, and bye.